Right. I was going to walk back and forth, but right, almost on my point. So, just a thing to talk to me about. As indie developers, or indie developers in general, we all find that tools are useful. We love tools. These tools fall into two kind of cases. You've got, or they fall on a spectrum. You've got tools that are very general, that are used across many projects, and you've got tools that are very kind of project specific. So something like Unity itself is a pretty general purpose tool that you might build a very specific kind of level editing tool or like an AI debugging tool just for your own project that's only useful in that one situation. So yeah, so Unity is general, but it also allows us to build more project specific ones on top. Now, before I carry on, who is a coder? Hands, okay. Right, who here isn't? Okay, alright, so most of the coders, that's cool. So for the coders in this talk, I'm going to try and give you guys just kind of an overview of some opportunities that exist within Unity for kind of developing little things quickly that can speed up your development, make it easier to get stuff done. For those of you who aren't coders, I'm going to show you some opportunities for things to ask your coders to do. For those of you who don't use Unity, I don't know, just like Poker Phones or something. Why tools for indies in particular? Why do I think indies are particularly relevant to tools? Partly, we have kind of less money, less time, less resources. It's more important that we can do stuff with what we've got there. Now, choosing to spend any of that on making tools rather than making a game is obviously something that has to be taken seriously as a decision, but by making smart decisions about tools, by kind of just taking stuff off the shelf and building things quickly and so on, we can get stuff done before we run out of our rent money or before we run out of personal motivation and have to be evicted and give up and go and get a job in banking or something. So there's that. And also, I find as well, personally, the transition costs of work are quite high in the sense that if I'm working on something part-time, if I'm working on it at the end of the day, just after I've got home from 24/7, then it takes longer to get back into where I was. It takes longer to kind of remember all the things that I was in the middle of doing. If I'm able to sort of sit down for a week and just power through balancing the AI or something like that, then that's great. But often I don't get the opportunity to do that, and I need to be able to get to where I was quickly, which means I need to be able to do things like find information very quickly. And having tools that can expose things for me, that help me kind of just jump into where I am, that frame everything in a way that's very natural and appropriate for the task at hand, speeds that up a lot and reduces the transition costs. And yeah, just be careful as well that you don't get stuck in building tools forever. This is like newbie programmer mistake 101 when they get into game stuff, is that they're all making engines rather than games. Sort of thing, and that doesn't happen quite so much these days, but once you get into some of this stuff, you can kind of keep pursuing it further and further. Particularly because we're in these, more frequently we don't have schedules to keep to, we don't have a solid grasp on when we're going to start sort of behind. That's a bad thing for other reasons anyway, but if you're going about that, then one pitfall you can fall into then is that you then get stuck making tools rather than just making a game. So be aware of that. So, the life cycle within the Unity editor. Does anyone recognize this diagram?
Yeah.
Hey, excellent. So I made this diagram of kind of the main hooks within Unity that you can stick code on top of, kind of that run anytime during the gameplay loop, what order they come in and so on. So the first thing to understand about the editor life cycle is that isn't there. There is no update pump, there is no game loop in play during the editor. Everything's much more event-driven. In the general case, if you just open the Unity editor and then just sit there and just leave it on screen, it won't do anything. It will do nothing until you do. This is slightly light. There is, in fact, an update that takes, I think, every 100th of a second that you can hook into, and there are a few other places here and there where you can attach to get kind of an idle loop sort of thing. So there are a few things like if you want to write your own autosave for the editor, then you would want to use that sort of thing. But for the most part, you don't need to do those, and the things that I'm going to focus on today don't require that kind of low-level hooking in. So, right, the two most common things that people usually talk about when they're talking about extending the Unity editor are the editor and editor window classes. I'm going to give you a very, very quick info on what those are, but we're not going to go very much into them, partly because I think that if you're getting to the point where you're building stuff around editor and editor window, then you're building something that's bigger than what I can explain in half an hour anyway. So editor, you can write your own code that's derived from editor, do a custom inspector. So you click on your game object, you click on your asset, and in the inspector, the little block of properties that you get there, you can just completely customize that. You can replace that with whatever you like. So I can use that for showing like all sort of computed bits of information that perhaps only makes sense at runtime. And you can also do some custom scene view things and custom like editor handles and 3D tools and sort of things. And then editor window just lets you have a window that you can do whatever you like with, and it will support docking and things like that. Yeah, both of them are based around Unity's scriptable object system. So you have like an on enable when the window is opened or when the inspector starts being opened up. You have on disable again when it goes away. And both of them are using the Unity immediate mode GUI system. So like GUI.label or GUI layout.button and things like that. All of that runtime is there, and there's also a bunch of like additional methods in the editor to make it really easier for you to sort of throw like a text field or a field for a float or things like that, just to sort of throw this in there. Or you can start digging into rendering and just like drawing an arbitrary GL there as well, which can be handy. I've done like sort of graph view, sort of line view type things in there before. Yes. Yeah, so editor window gets very useful callbacks as well. So if like you change what you've got selected in the hierarchy view, then it gets called back for that. If something in the project changes, like you add a new asset, it gets called back for that as well. But anyway, there's a lot of potential in there, and most of the packages you see on the asset store that extend the editor in various ways are based around these. It's a massive topic, and I'm not going to go too much into it. I'm going to cover a few slightly smaller things that you can like just do in 10 minutes, and then suddenly have something that's like speaking to your development a bit more. So, the first of these is the asset post-processor class. So asset post-processor allows you to run a little bit of code whenever an asset is added to the project, deleted from the project, moved around the project, etc. So some really simple things that you can do with this. You can, for example, detect if, like normal or NRM is in the name of the texture file, and automatically mark it to be a text, automatically mark it to be a normal map. Or you can automatically turn on the generate line map UVs button for all files in a particular folder, because you have the full path of the asset that's coming in. And you can, for example, add components and models. And this is one of the really nice things. Ordinarily, what I do when I start learning Unity is I take my FBX file or my Max file that I've been given, and bring it to the scene. I'd start adding stuff to it, and then I'd save it back as a prefab again. It's meant that I had like a model file and a prefab as separate things. And if the artist then did more work on a model, and suddenly there were more bits, or they renamed something, or they broke something up into pieces or whatever, my prefab would break. And I have to go through and kind of rebuild it and manually connect all of the mesh pieces up and so on. If you can do it this way, so it's kind of fully automated in the pipeline, you can change the model file, or replace the model file entirely, and have the pieces get wired up again. So there's quite a lot of potential with that. And then, yeah, the complex case is like setting up an entire sort of XML file containing information about which components to add and like which image filters to run on the texture and all kinds of things. You can have a full framework based around this stuff that gets carried out by one of these. So I'm trying to show a little example now. It's not going to look right on the screen, maybe. Okay, so here's a really simple sample post-processor script. So we've got this on pre-processed texture function here. And so you can see what I'm doing is I'm saying if the path, which is the full path from the assets folder to the asset, including the file, if it includes normal or includes NRM, then set grab the texture represented for it and set the texture type to bump, which is the code representation of it being a normal map. As simple as that. And Unity will then run this little function on any texture I enter the project in any folder, anywhere, kind of before it does all the processing on it to convert it to get ready formats and so on. It will do all of that. And then further down, I've got this on-process model script that will run after a model file has finished importing. And this one, so there's something similar to the XML thing I was talking about. It grabs from the user data property on the asset, which is something that you have to set from code via other tools. But it grabs from that user data the path to a file, which is a text file that contains a list of component types I want to add. So it gets all the lines from the file, with this line here. Then it retrieves the types of all possible components that are presently loaded into the editor, and then goes through each line, finds a component by that name, and if it's found it, then it adds it. So I can very quickly sort of point all of my models in my props folder as a file that says rigid body, box collider, audio source, or something, and then all my models have a rigid body, a box collider, and an audio source added to them automatically whenever I drop anything into that folder. Obviously on its own it's a little bit pointless because you're almost certainly going to also configure these components to do interesting things, but you can see that if I can open a file that contains the names of the components, I can also put information about how some components are in the file as well. So, just to give a tiny demo of the texture process on there. So I've got this texture here, this constructor underscore n, that I've imported it as a reflection map. Just because it's wrong. And if I rename it now, to say NRM in the name, now that I've renamed it, it's automatically set to be a normal map for me. Yeah? So if you have a naming standard for this sort of thing, you can use it. So, I mean, it's not that hard to go through by hand, select every individual file, but it's a nice way to ensure no mistakes. So, that's that one. Right. Okay, so the next simple kind of linchpin of developing little tools for yourself, using the high flags. Every object in Unity has a high flag setting, which is very badly documented. No one ever talks about it. But what it will let you do, you can set an object to not show up in the hierarchy on the inspector. And I've used that. That's very, very handy for hiding all of my geometry in my scene, so I can just focus on gameplay stuff. I just mark everything else as hidden, and then it's all there, but keeps it clean, so I can just focus on the interesting things in the list. Ready for being edited, so that uppity designers don't start fucking with my shit. I'm ready for being saved. It's very handy for creating temporary markers and tools within the scene. So, what this allows you to do is you can actually build tools up using completely regular, Unity game objects, and just set them to, not show the inspector and not save into the file and things like that. You can just dump whatever you like in there and keep them hidden and temporary. This is actually, and then of course you can just use completely normal API to mess with them. You can just set positions on things with transform.position. You can do whatever you like with them. And this is actually how Unity's own 3D previews of anything works. Every single time you're looking at a preview of a material in the inspector or something like that, what it's actually done behind the scenes is it's created a sphere in your scene that is marked as hidden and not savable, along with a couple of lights and a camera, and kind of built a little micro scene in there. They use some custom APIs to make sure that the camera can only see their little bits that they've added, but they're then able to just render the scene through that special camera into the bottom of the window, and that's how they do a preview. So you can do quite a lot of fun things with that. An example that I've done, which again I will show you, is spawn points. So I've got just an empty game object in my scene here, and if I add to it a spawn point script. This is something that I actually ran into on my current project. So I've got this spawn point saying character should spawn here facing, sort of standing in this position, oriented along the blue arrow, in the posture that I can set here. So I can say whether standing or sitting or crouching or whatever. And that's fine as far as it goes. But I've got 500-ish spawn points in my level, probably more than that these days. And as I was saying before, part of the point of good tools is being able to answer questions quickly, for me to be able to see the current state of things. So if I'm looking at some situation, I can't tell from looking at it whether or not there are spawn points there or not. Now, so what I really like to do is I'd like to set up some kind of visual representation that will persist even when I don't have it selected. Now, Unity has an approach for this called gizmos. Makes it quite easy to just draw like a box or like a wireframe sphere or a little icon or something like that. So what I could do is I could have drawn a box and colour-coded it to indicate posture. Or I could have drawn an icon and picked a different icon depending on posture. But what I really wanted to do is I really wanted something that gave me a much better indication of like when I'd be able to see someone from distance. I really wanted something that was a pretty accurate representation of what someone who would spawn in that position would look like. And that way it would make it much easier for me to sort of align them with things and make sure that they were kind of just that way behind a pillar so they could jump out and go boop, and things like that. So what I ended up doing was, I'm comment these bits. I'll just show you the result and I'll come in and explain it briefly. So read the file, and then there we go, press it. So, yeah, and it updates correctly according to the posture that I pick. I can move it around quite comfortably, I can select it. But note that there's no other components here. It's still just a small point script. I somehow managed to make a 3D mesh gizmo, which isn't in their API, so how did I do that, huh? And the answer is, I actually did have components. When I look at my Ponderal Gizmos function I've got here, I've actually added a mesh filter, a mesh renderer component, which is what you would ordinarily have for rendering a static mesh. But I've set the hide flags to say, don't save, not editable, hide in inspector. There is a hide and don't save flag, but for one reason or another it didn't quite work correctly. Yeah, so by setting that up, I'm actually able to have the components present, but just not have them visible in the inspector, not have them get in the way, not have them be things that I can start messing with. And because their mark is not saved, well, they won't get included in my build. So, yeah, I did the same thing to materials, and then I had a step of going through and loading an asset file that has the mesh for that posture in it, and then just apply it to the mesh filter. And then once it's all done, if I change anything, then I make all of the scene views repaint. The scene view class, by the way, not documented at all, full of everything useful. So, yeah, like use IntelliSense for shenanigans, as I will explain later. So that's just a little example of using actual Unity objects and just hiding them as a way to build some tools on quickly. Right, property drills. Another useful thing. New in Unity 4. They allow you to kind of do little bits of custom inspector stuff without having to do an entire custom inspector itself. So if it's just like, well, I want to display all of my things in inches rather than meters or something like that, then you can use the draw to like add units on the end of things and do things without having to go through every single thing that uses a variable anywhere. So it allows for a more intuitive user interface. You can present data rather than just in kind of a flat, this is a number, you can take something that's a bit more natural to work with by reducing your cost of working with it. It gives you opportunities to do things like validation, so you can make sure that it doesn't go outside a certain range or that it's not zero. And yeah, it allows you to build like really, really tiny tools that just live with individual variables. So we have some examples of that as well. Yeah, so and once you've built these things up, you can apply them to individual variables on individual components, or you can apply them to an entire type. So I don't have an example of custom types coming up. I do have one in individual errors, but custom types, for example, I have a little class called ranged float that I use to represent like a minimum maximum range between values. And rather than it just being displayed as minimum maximum, it's often useful for me to be able to sort of, well, I mean, firstly, getting it all to one line is helpful. Secondly, being able to do things like toggle between min and max versus average and deviation is helpful. And there's some other sort of utils and so on I can contact. But having implemented a drawer for it, like anywhere I use that class, anywhere throughout my code, it will now show up with this nice single line representation where I can toggle the different ways of displaying it and so on, which is helpful. But I have a demo of a couple of sort of per variable things. So, that's 1 point. There you go. So I've got here an inspector with drawn properties component with a usability chart slider, with percentage slider from 0 to 100%, and a descriptor file with a browse button that will let me just pick a file and then just plug the path of it into that field there. And on the code side, this component is super simple. On the code side, this component is just that. It's still just these two variable declarations, one for a float, which is actually going to be between 0 and 1, because it's more useful usually than by between 0 and 100. And minus root fudge is a string, but I mark them up with attributes, percentage and file path, that describe how I want Unity to present them. So these attributes are things that I defined in my code. Digital like that. Well, it's empty. It's just a declaration that says this thing exists, and it is a property attribute, which is Unity's class for this. And then when I start looking at the so this is the drawer for it, and it's a little complex and probably not worth going through fully line by line, but you can see in particular I've got like a horizontal slider going on there, and then I deal as well with just displaying the value as a percentage, multiplying it by 100, rounding it into an inch and things like that. I just sort of take it at the bottom. So the whole thing is just I get given a rectangle, a property to draw, and a label to draw next to it. And it's completely up to me exactly how I present it and how I make it editable within that space, kind of thing. And a similar thing for the file path of Drawer, is I just say, okay, well, I'll put a little button in there, saying browse, and if it gets pressed, then I'll use the open file panel to retrieve it. Just the way of sort of setting file path. So yeah, so that's those. But like now those are set up, I can just apply those to any value in my code base with that little attribute marker. Percentage of file path. And I can extend these further as well. I could say maybe I want it to be a percentage between 0 and 200% or something like that. I could put other kind of range constraints in that. That's kind of up to me, up to whatever the designer tool needs. So, what was next? Ah, yes. Yes. Cheating is good. So, the Unity source code is not an option for probably any indies or really most small studios. As far as we know, I mean, maybe in the light of Unreal's announcements, that's going to change soon, but I doubt it. So, having source code and kind of figuring out how they did stuff, like that's hard, right? Except the ship source code. Yeah, it totally includes the source code, guys. Didn't you know? Yeah, sort of. So, what you can do, at least as far as the editor is concerned, is you can reverse engineer it. They write the editor in C#. They don't obfuscate it. So you can take ILSpy, you can take MonitoVar, and you can load up the Unity editor DLL and take it apart and see how they did most things. It still takes a bit of time, and if you are kind of like jumping to just sort of decompiling and finding needed stuff, it's probably fast to check documentation first, but the documentation is pretty bad in a lot of cases. You can also use reflection for unsupported runtime shenanigans, which is not as much minuend as it sounds like. So, for example, I've got conversation sequences in my game. And I've got a little custom asset, a custom inspector, for sort of saying, okay, it's this line dialogue, then this line, then this line, then this line. They don't provide any API in the editor for playing back audio, not like as audio preview. Now, it's possible, I suppose, that there was some way to do it using an audio, like a hidden audio source in sync, but what I did instead is I went and said, well, okay, I mean, they can do it somehow for their audio clip inspector, and that's in C#. So how about it for my audio inspector? I've got to look at how they did theirs. And through that, I found a hidden API that's marked as private sample. You can use the reflection functions to get at these things. It will break. It will break whenever they upgrade it, and it almost certainly has broken already in the very latest build of Unity, but like, you shouldn't be upgrading your version of Unity kind of without thinking of the fact that things may break anyway. So, and most importantly, Unity don't really appear to mind any of this. Ordinarily, I wouldn't stand in front of a room full of people and be like, yeah, you should totally just like hack open everything and reverse engineer and steal all of everyone's secrets and so on. They've had talks at Unite on how to use IL-Spy to like decompile it, so they don't seem to care. I think they're perfectly happy with it, as long as you don't then complain when they change stuff that they never make public. If you're going to purloin the secrets, like, you know, don't cause a fuss when the secrets turn out to be stable. Good same thing. Yeah, so coming to the end. Yeah, there's far too much stuff to cover about extended Unity that I can go over in just a half-hour talk. Feel free to ask me stuff. I've probably time for questions in a bit. Okay, maybe a little. But yeah, experiment. I mean, anyone who's seen me at Lug recently may have seen, I think I was there last month, I showed them some toys that I've made. I've written a menu item that, when chosen, opens a window with an inspiring picture of David Halverson. I've made Aris Pronvekius, who's I think the lead graphics guy at Unity. Every 20-30 seconds he'll just slide out the corner of the scene view and just like watch what you're doing with his eye will follow the cursor. And then after that I decided to implement achievements for Unity Editor. So if you add a text to the project you get like, by the way, you have an achievement unlocked. So yeah, and like just in the process of doing that silly little stuff, I covered loads of chunks of the UI and discovered many things about how to do something in Editor, which was really useful. So, lastly, that's me. I probably should have made that bigger. And that's our promotion. I guess that means I'm really indie. So, yeah. Time for one question? One question, anybody?
Make it good.
Anybody with a question? Yes.
Yeah, so Unity 4.6 coming out soon, and it's
Yes.
got loads of GUI changes.
It has a new GUI system for the runtime.
Is that going to affect how you do
No.
extensions?
No, the editor is still implemented in the current GUI system. I mean, the GUI system that's implemented at the moment in Unity, the reason they're replacing it is because it's bad for games, but it's great for tools. It's always been great for tools. Being able to just be like, stick up a button and then like the result of that, save it here, kind of thing. It's possible, I think it's unlikely that you might be able to build a tool's user interface in the new GUI system and then like render it into an actual window, but it will be hard.
Cool. Good.